All right, hello everybody. Welcome to our lesson for November 29th. We're going to look at a revolution in science. So our objectives and standards are to analyze the challenges and conflicts that science faced and explain the advances made in science. So our desired result is what changes occurred in science. Okay, so think about this because at the end of the lesson there will be a question related to this. So what changes occurred in science? Vocabulary preview, we have geocentric theory was the Earth-centered view of the universe, the heliocentric theory, which is the sun-centered theory of the universe, and then the scientific method, which is a logical procedure for gathering and testing ideas. So forming modern science. So prior to 1500, scholars typically accepted the views of the Bible or the views of ancient Greeks or Romans. They believed in things like Aristotle in that left-hand side there and Ptolemy on the right-hand side. And very few challenged the views of the church or came up with their own ideas. The geocentric theory that the Earth was the center of the universe was used from Aristotle, like we said, Ptolemy, and also taught by Christianity. But starting around the middle of the 1500s, the scientific revolution would change and challenge these views. So this shows you the geocentric theory, where the Earth is the center of the universe. You can see that the Earth is placed here in the middle, circle that for you, and then that everything else, including the sun, revolve around the Earth. That was a theory that most people accepted prior to the scientific revolution. Now, new thinking begins. The new way of thinking about the natural world is known as the scientific revolution, and this included careful observations and a willingness to challenge accepted beliefs that were a major point of it. The reason this occurs is because people were making travels around the world during the Renaissance and witnessing new ideas and different things, and also the exploration of the New World. So as people were traveling, especially in terms of navigation and navigating the oceans, people began to question some of these old ways of thinking. There were also advances in tools, especially in astronomy and geographic instruments, that allowed for new studies and challenging old beliefs. And also there's an increase in a great deal of mathematics scientific research as well. So scientists are going to begin to view new discoveries that challenged old ways of thinking. So a challenge in astronomy. Common sense and authority typically back the view of what we talked about, the geocentric theory about the Earth being the center of the universe, but it did not accurately describe the movement of the sun, moon, and the planets. Now, one of the first people to look at this was a Polish cleric by the name of Nicholas Copernicus, and he began studying the geocentric theory for 25 years. So he studied the motion of the planets and the Earth and everything like that for 25 years. And he believes that the Earth, the planets, and the moon rotate around the sun instead of everything rotating around the Earth. And this soon becomes known as the heliocentric theory, where the Earth is not the center of the universe, but the sun is the center of the universe. But Copernicus is not going to publish his findings until 1543. But a copy of his book on the revolutions of the heavenly bodies was received by him on his deathbed. So there's Nicholas Copernicus there, and then this here shows you the more typical view and what we know today to be the typically true version of how the universe works. So we have the sun in the middle, and then of course all the planets, including the Earth and the moon, rotating around the outside. There was little concern over Copernicus's heliocentric theory in the beginning. People really didn't pay too much attention to it. However, soon others began to build off the study of what he had started. One of these was Tycho Brahe, this gentleman right here. He was a Danish astronomer who recorded the movements of the planets for many years and had a large amount of data. Unfortunately, he really didn't know how to read that data or understand that data. But a brilliant mathematician and an assistant to him, his name was Johannes Kepler, his picture's down here. He studied the data and discovered that there were certain mathematical laws that he could apply to planetary motion, and this is going to help prove Copernicus's heliocentric theory. Discoveries of Galileo. So there were also new discoveries made by an Italian astronomer named Galileo Galilei. His picture's there. He actually built his own telescope to study the heavens in 1609. There's a depiction of it there. And in 1610, he published a book called Starry Messenger that described his observations. Some of the things he examined were that Jupiter has 4 moons and the sun has dark spots on it. The book also stated that the moon was rough and uneven. So when he looked at the moon through his telescope, he could see that it wasn't perfect and pure and smooth. Many people had the view that the moon was smooth and perfect and, was a pure substance, but like Aristotle had claimed. But Galileo says, no, I saw it, and the moon's very rough and uneven. So this shatters some previous scientific views as well. And again, these observations that Galileo is going to make also help prove the theories of Copernicus. Challenges with the Church. The findings of Galileo frightened both Protestant and Catholic leaders. They were afraid that if people began to think that the Church was wrong on astronomy, like how the Earth and the Sun move, that maybe people would begin to question their authority in other areas. So in 1616, the Catholic Church warned Galileo not to defend Copernicus's ideas. And Galileo, he agrees, he remains publicly silent about the ideas of Copernicus, but he continued his studies in private. In 1638, he published a dialogue concerning the 2 chief world systems, and when the Pope found out in 1633, he was obviously angry and ordered Galileo to Rome to stand trial before the Inquisition because the book, Dialogue Concerning the 2 Chief World Systems, discussed the theories of Ptolemy and Copernicus, so 2 different views. Remember, Ptolemy was in favor of everything moving around the Earth was the center of the universe, and Copernicus had said that the sun was the center of the universe. And Galileo discussed both these ideas in his book, but he clearly favored the views of Copernicus, so the Catholic Church was not happy with him over that. So there's going to be a trial for Galileo. In front of the court, Galileo, under the threat of torture, knelt and renounced the ideas of Copernicus in a statement of confession. Now, he will never again be a free man, and he will be placed under house arrest and died in 1642. However, his books and ideas are going to continue to spread all over Europe still. And actually, in 1992, the Catholic Church finally acknowledged that Galileo had been right all along. And this picture here is a picture by Joseph Nicholas Robert Fleury, and it's entitled Galileo Before the Holy Office. There's going to be some more advances in science as well. So the revolutionary ideas of Galileo, Kepler, and Copernicus eventually led to the creation of the scientific method. And maybe you've heard about this in other science classes or whatever, but this is when the scientific method came about. It is a logical process that contains questions, a hypothesis, an experiment, and an unproved assumption. And it will be advanced with the help of 2 thinkers in the 1600s. In England, Francis Bacon, his picture there, and then France, René Descartes, who we've kind of already talked about a little bit. His picture is right there. Now, Bacon was an English statesman and writer who had an interest in science, and he attacked medieval scholars who relied on the works of Aristotle and other ancient thinkers. So he says kind of, hey, think for yourself. Bacon then urged other scientists to use experiments to come up with their own conclusions. Now, Descartes, he was also in favor of scientists abandoning old ideas, and just like Bacon, but he is going to argue that mathematics and logic should be found to find the correct answer, not just experiments. So Bacon says use an experiment to find the answer. Descartes says use mathematics to find the answer. But in the long run today, we know, maybe you know from science class today, that scientists typically use both in forming conclusions. The idea from Bacon of using experimentation, and also the idea of using mathematics, which was the idea of Descartes. Gravity and Isaac Newton. The old views of science are now being shattered by the work of new scientists at this point, and Isaac Newton thought he could help add to science with another breakthrough. He was studying mathematics and physics at the University of Cambridge in England, and he began to think about all physical objects are affected equally by the same forces. So he comes up with a key idea that links the motions in the heavens with the motion on Earth, and this is known as the idea of universal gravitation, or gravity. So it's stated that every object in the universe attracts every other object. So this is when the idea of gravity, about why we're not kind of floating around in outer space or floating around the sky, that gravity holds us here on Earth, was found out by Isaac Newton. Maybe you've heard the story of how he was sitting under the apple tree and an apple fell and hit him in the head, and he said, why does it fall? That's part of the story that comes from Isaac Newton. In 1687, he also published the Mathematical Principles of Natural Philosophy, and it stated that the universe was like a giant clock where all the pieces worked together and could be expressed mathematically. And he also believed that God was the creator of the universe, that God was the clockmaker that set everything in motion. The revolution in science is going to spread to other places around Europe as well. There is the use of careful observation, and the scientific method became important in other fields as well. 1590, we have Zacharias Jensen right here. He invented the microscope. The 1670s, Anton von Leeuwenhoek examined bacteria and blood cells for the first time. This gentleman right here. In 1643, Evangelista Torricelli developed the first barometer. A barometer is used to measure atmospheric pressure, and it's also used to help predict the weather. And then we have these two gentlemen here, Fahrenheit and Celsius. Maybe you've heard of them before in terms of temperature. But in 1714, Gabriel Fahrenheit, he's right here, created the first thermometer with water, with water freezing at 32 degrees. And then 1742, we have Anders Celsius, who invented another thermometer with a different freezing point for water. Okay, so Gabriel Fahrenheit says water freezes at 32 degrees, and Anders Celsius says water freezes at 0 degrees. And then finally, we're going to see some changes in medicine and chemistry. In terms of medicine, in the Middle Ages, people accepted the writings of Galen. Now, Galen had never dissected the human body. He only had dissected the body of pigs or other animals. So he just assumed that the body of the pig or another animal looked the same as a human, which not always true all the time. So Flemish physician Andreas Vesalius began the dissection of human corpses, of human bodies, okay? And he published his observations in a book. And the name of the book was On the Structure of the Human Body. It was published in 1543. He is right here, okay? And it showed detailed images of the organs, bones, and muscles, okay? So this is a big advance in science as well, and medicine for that matter. Another important person is Edward Jenner, who kind of came up with vaccination. Now, inoculation, or trying to prevent people from diseases, had been around for centuries, especially in China, but it was very dangerous and it wasn't always safe. So Edward Jenner, he was a British physician in the late 1700s who discovered a way to safely vaccinate people from smallpox. So again, this is another thing that's going to not only advance medicine, but advance the health of the human race as well. And finally, in chemistry, we have Robert Boyle, who proposed that the world was not just made up of 4 elements like Aristotle had proposed. Aristotle had proposed the world was made up of 4 elements: earth, wind, fire, and water. And Robert Boyle is going to propose it's not. It's made up of tiny particles. And he also came up with Boyle's law, which explained how various temperatures, volumes, and pressures of gases impact each other. So another important part for chemistry as well. All right, so summarizing up here, people looked towards the skies to explain how and things why it worked. We had Copernicus, Galileo, all those different people. We also have other scientists who are going to look on Earth to explain things, people like Sir Isaac Newton, and other people are going to study chemistry and the human body. And that also goes along with medicine and chemistry, looking at the body and knowing the organs, the muscles, blood cells, looking at tiny particles that make up the Earth. So all these different things are definitely going to help advance science and society. All right, so please try your best on the questions that follow, and let me know if you have questions, and I'll see and talk to you soon.